This week at ACE, we're going to do a unique test for one of our allied forces that's associated with NATO. A 7.62 by 51. The grouping is rather tight. It is all within 2 centimeters. So basically, here's the target. The grouping will be a shot on the top, a shot in the center of the target, on each side, and again at the bottom, all within this circumference here, this grouping, a very, very tight, near grouping. Presently at NATO, on vehicles, the glass is 50 millimeters thick. We're reducing that. We're going to be shooting a glass that's 28 millimeter thick. Let's take a look at the results. Again, the bullet is a 7.62 by 51, 6 shots, all within a very tight circumference and grouping. The shooter is Lieutenant Steve Cashin. The weapon is an M14. Lieutenant, load your weapon, go down range. Let's do this. Fire! Fire! To keep the integrity of what we're doing, we're not going to actually touch the glass sample, but you can see here that there's the lead bullet. It's caught in the glass. So this is how the bullet started. This is the first shot. It's right there. The glass is pulverized, all within, I would say, maybe 1.5 centimeters around the hole. You can see that the glass has turned to powder. There's quite a bit of a bullet fragment associated with that. Now the goal is for our sniper to shoot another shot just below that, just on the very edge of this present hole, and the next one. Then he's going to be shooting at 3 o'clock, 9 o'clock, 7 o'clock, and 5 o'clock of the original. So we're going to now ask the shooter to go back and just continue shooting. Also, if you notice, all the fragmentation came forward. There's absolutely no fragmentation behind. The glass is perfectly still flat, and the integrity is kept. Looking at the center of the glass, the top is exposed for our viewing. You can see that the integrity of the laminate that's caught between the 2 layers of glass is still there. It's very, very impressive. So let's continue with the test. If we look at the grouping on our third test sample here, the grouping is keeps the integrity of the spirit of what we're trying to do, with each shot being approximately 2 centimeters apart. You have the first one here, you have the 3 across, we have here our 5 o'clock, our 7 o'clock is a little low, but it's still within the 2 centimeters. You see the glass is totally pulverized, the bullet fragment is still inside of each one, so it captured the projectile. You see all the glass fragmentation coming forward. Again, this is a bullet traveling at 2,400 feet per second, about 820, 840 meters per second, at less than 30 meters across. That's about 10 meters from shooter, from muzzle to glass. What is interesting though is because we put laminate on surface 2 and laminate on surface 4, allowing the glass to absorb a lot more of the energy, and for the construction, the composite that we created to act more of a shock absorber, we're intrigued to find that glass 2, surface 3, and surface 4 actually lifted and separated from the 2. They're not bonded together by any adhesive, they're just tightly assembled together. And the lifting is about 2 millimeters of separation. Again, the glass is tightly covered on all 3 sides, not the top side, so that we measure and evaluate what is happening. On the reverse side, come take a look at this. On the reverse side, as you'll notice, absolutely no penetration. The glass really did bow, and how each time that glass was hit, it pulled back and pulled back, absorbing each projectile. So as a success rate, this is positive. Is it 10 out of 10? No, it's 3 out of 3. We're going to continue doing some R&D on this and get back to you with a report, as we are very satisfied where we're going with this right now. Thank you for watching this video.